What's happening, dogs? Mr. Allen here. We're about to solve for x in this dope trig equation here, man. Woo! Love them. This is a little weird. It seems like too simple, but also I don't really know what the heck's happening. Here's what I'm going to do. I'm going to set this thing equal to 0, and I'm going to change cotangent into terms of sine and cosine because I'm crazy like that. You ready? So we're going to have 2 cosine x minus cotangent x equals 0. Then I'll change that to cosine x. Cotangent is cosine over sine, so minus cosine x over sine x equals 0. Now what I'm going to do here is I'm going to factor out a cosine as my GCF, all right? So cosine x, then I'll be left with 2 minus, and I'd have 1 over sine of x equals 0. Now what's 1 over sine? That is cosecant. So I'm going to have cosine of x, and then we'll have 2 minus cosecant x equals 0. Now I have 2 factors I can work with, set them equal to 0, and solve. So we're going to have cosine of x is equal to 0. Cosine x equals 0. When's that going to occur? That's up at 90 or pi over 2 and down at 3 pi over 2. So pi over 2 and 3 pi over 2. Beautiful. Next one. We've got ourselves 2 minus cosecant. So I'm going to subtract 2. I'm going to show a couple steps here. Negative cosecant x equals negative 2. Then I'll divide by negative 1, so I get cosecant x equals positive 2. All right, so cosecant equaling positive 2. Cosecant's tied with sine, so we can think of those ones as like 1/2 for sine. Where does that occur? You can also think of this as hypotenuse over opposite, right? And we'll draw a little triangle. I'm a triangle fan. Not everybody is. Some people make fun of me for wanting to draw triangles. I love triangles. I love them. You know, I love geometry. I like triangles. All right, so we're positive here. Hypotenuse over opposite. So my opposite's 1. That's 2. This is going to be root 3 right here. So this is a pi over 6 right there. And where else is cosecant going to be positive? It's also going to be positive in quadrant number 2 because it matches up with sine. So I'm going to have myself a 5 pi over 6 for that one. So we have pi over 6, and we have 5 pi over 6. Those are my 4 solutions for this one right here. Boom and boom. Beautiful. Now, some of you might be wondering, like, how do I write this unbounded? Now, I know it doesn't say in the directions, but, you know, I'm here to give, okay? I'm a giver here with the math. I want to help you out. So I'm even going to show you how to do this unbounded if the question said unbounded, from negative infinity to positive infinity. So for the first one here, we're going to take this pi over 2, okay? Pi over 2. Now, what's my jump to get to 3 pi over 2? It's pi, right? So, or 2 pi over 2, which is just pi. And if I did that again, right, if I added 2 pi over 2, I'd get 5 pi over 2, which brings me right back to this guy right here. So I could safely add pi times n, some integer n, whether it's positive or negative, or sometimes we'll use k in the directions. We'll say n for this one. If I add pi, which is 2 pi over 2, it's going to get me to this one, and then back to this one, and to this one, and to this one, and boom, 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 boom. Beautiful. Didn't need to write 2 things for that one, just the 1. It's awesome. Over here, we aren't going to be so lucky. And I'm going to pop back into this triangle right here. If I'm at pi over 6, to get over to 5 pi over 6 is 4 pi over 6. But if I added 4 pi over 6 again, I'm not going to end up on this guy right here. I'm going to end up somewhere else, right? It's not going to work. So really I have to break this one up twice. I'm going to have pi over 6 plus, we're just going to have to go coterminal with it, 2 pi n. And then I'm also going to have, so this, we're going to have this, and then this guy here is going to be 5 pi over 6. Same thing, plus 2 pi n. Beautiful. So those are my 3 solutions here, or 3 unbounded ways of writing it here. Initially 4 solutions for our bounded, and then we got our beautiful unbounded ones there. Dang, man. Bonus math. You're welcome. You're welcome for the bonus math. You guys have a wonderful, fantastic, and dope day.